So the definition of dot product. The dot product of vector u equals to u1, u2, and vector v equals to v1, v2. So u dot v, the two vectors would equal to u1, v1 plus u2, v2. On the other hand, the dot product of vector u, if vector u has three components, u1, u2, and u3, and vector v has three components, v1, v2, v3, then the vector u dot v would equals to u1, v1 plus u2, v2 plus u3, v3.
So these are the properties of the dot product. The most common ones are the commutative property and the distributive property. So the commutative property is u dot v equals to v dot u, and the distributive property is u dot v plus w equals to u dot v plus u dot w. So here's an example of finding dot products. Given that vector u equals to 2, minus 2, and v equals to 5, 8. So to find the dot product of these two vectors, using the formula, we need to multiply u1, v1 and u2, v2. So 2, minus 2 dot 5, 8 would equals to 2 multiplied 5 plus a negative 2 multiplied with 8. So the result will be negative 6.
Now we're going to be introducing the angle between two vectors. The angle between two non-zero vectors is the angle theta between their respective standard position vectors. So if theta is the angle between two non-zero vectors, u and v, then cosine theta would equals to u dot v over the magnitude of u times the magnitude of v.
Here's an example of finding the angle between two vectors. For vector u equals to 3, negative 1, 2, and vector v, negative 4, 0, 2. Cosine theta, using the formula, would equal to negative 12 plus 0 plus 4 over square root 14 times square root 20. And the result would be negative 4 over square root 70. Because u dot v is smaller than 0, the angle theta would equal to arc cosine negative 4 over square root 70, and the result would be 2.069 radians.
Definition of projection and vector components. It is really important to know that W1 is called the projection of u onto v, or the vector component of u along v, and is denoted by the following equation. If u and v are non-zero vectors, then a projection of u onto v is given by the following equation.
So here's an example of finding the projection. Find the projection of u onto v for the vectors u equals to 3i minus 5j plus 2k and v equals to 7i plus j minus 2k. So the projection of u onto v using the formula would equal to 12 over 54 times the vector v, and the result would be 14 over 9i plus 2 over 9j minus 4 over 9k.
The definition of double integral. If f is defined on a closed bounded region R in the xy plane, then the double integral of f over R is given by the following equation, provided the limit exists. If the limit exists, then f is integrable over R.
These are the properties of double integrals. Let f and g be continuous over a closed bounded plane region R, and let c be a constant. And the properties are given below. So here's an example of evaluating a double integral. So evaluate the following double integral, where R is the region given by 0 is smaller or equal to x, is smaller and equal to 1. 0 is smaller or equals to y, is smaller and equals to 1. Because the region R is a square, it is both vertically and horizontally simple, and you can use either order of integration. For example, you can choose dy dx by placing a vertical representative rectangle in the region, as shown in the figure. This produces the following, and the result is 2 over 3.
The volume of a solid region. If f is integrable over a plane region R, and f of x, y is bigger or equals to 0 for all x, y, and R, Then the volume of the solid region that lies above R and below the graph of f is defined as the following equation. Here's another example. Find the volume of the solid region bounded by the paraboloid z equals to 4 minus x squared minus 2y squared and the xy plane. So the solution is by letting z equals to 0. You can see that the base of the region in the xy plane is the ellipse x squared plus 2y squared equals 4. This plane region is both vertically and horizontally simple, so the order dy dx is appropriate. The variable bounds for y is given, and the constant bounds for x is also given. So the volume is given by the following solution, which equals to 4 root 2 pi.